Hi Pre-Calc crew, time for lesson 5.7, the ambiguous case. This is one of the tougher lessons certainly in this chapter and maybe overall when we talk about trigonometry, so pay close attention, write down some good notes and should help you as we work in class on this tomorrow. So when we talk about that word ambiguous or ambiguity, as you can see these couple pictures here, these are a couple famous optical illusions which you can see. Probably in each case both an old woman and a young woman, and so you can focus on that a little bit, but that's a classic case of ambiguity where something maybe is not what it seems or maybe has more to offer than what it seems. We've been studying about various triangles and trigonometry and such in this chapter. Here's a little summary of what to use for various conditions that you're given when you're trying to solve some non-right triangles. And up to this point we've talked about these two, the law of sines, using, well, I made a mistake there, as you can see, angle, angle, side. This should be right, this should be angle, side, angle, ASA, sorry about that. We'll talk tomorrow about the law of cosines. Here's the two conditions you can look for that. But this is kind of a handy chart to help you out. Now, this particular chapter, though, or lesson, focuses on the ambiguous case, which is side, side, angle. Remember not to talk about this as angle, side, side class, but side, side, angle. Here's what this may look like. So the two sides you might be given here would be side A and side B. Then you'd be given this particular angle. So I think you can see it's possible to have more than one triangle under these conditions. One would be the dark triangle that you're given here, but then notice that this side A could really have the same length over here when we slant it in a different direction. So we'd still have the same angle, the same side B, and the same length side A, just slanted in a different direction. And so that's why this is called the ambiguous case, because there may be more than one solution for this. Now we have another chart here, so really pause this video and take some time to copy down this chart. This gives us sort of a strategy to use when we're going through these. Just need to add a couple things. So if we're given this angle theta, couldn't really write that very good. And down here this should also be theta as well. So as you can see, if your given angle is greater than 90, then it's a little bit easier, because then we just have one possible solution for the law of sines or maybe no solution. And it gets a little trickier when your given angle is less than 90. And we calculate this h value, which is the adjacent times the sine of the given angle, and that will determine how many solutions we have and what exactly to use. Notice here's that ambiguous case when that h value is less than the opposite side that's given, which is also less than the adjacent side. We'll go through an example concerning that here in a bit. So take some time and copy this chart down well. That will help you quite a bit. This is also summarized on the back of your trig card, but I just decided to put it in a more organized chart here for your convenience. Alright, we're going on to some examples here now. First of all, determine the number of solutions for each triangle. So we're not trying to solve the triangle, find missing sides or angles, just the number of solutions. And looking at that chart that we just had, that should be quite helpful. So first of all, on my first example here, again, these are all the side-side angle situations here. Sometimes not a bad idea to draw these out a little bit just so you can get a feel for what that looks like. So if I have my angle A, B, and C like this, here's my 63 degrees right here. Angle A, of course, is on the opposite side, and angle B this time would be right here. We'd call B the adjacent side. So that's what it looks like. And I would like to figure out that h value, because that's going to determine how many solutions I have. So h is always the adjacent side times the sine of that given angle, which is 63 here. In this case, my adjacent side is 25. So if I take 25 times the sine of 63, I believe I get this, 22.67. And if you look back to the chart that you just wrote down, you notice that here's this h value, and the opposite side is going to be the smallest side here if we write these in order, and then comes h at 22.67, and then comes the adjacent side like this. So if we have that particular condition, there's actually going to be no solution here. No solution. So the number of solutions then, of course, would be 0. Alright, so that's kind of odd, but that just goes to show how you can use this chart or this strategy for helping you figure these out. Alright, let's look at the next one. So the next one has a bigger angle here. We'll say that this is A and B and C like that. So here's my 105 degree angle here. Side A is across from that, of course, so that's going to be 73, 55 over here. So certainly we have that side-side angle situation. And now in this case, when my theta is greater than 90, all I have to do is compare the opposite and adjacent sides. In this case, the opposite side is greater than the adjacent side. And so when that happens, as you can tell by your chart, we just use the law of sines, and there is one solution. That wasn't very good, but one solution is what should happen here. Okay, so I'm not really solving these yet. I'm just trying to get a feel for how many solutions there might be. One next, find all solutions for this particular triangle, and as you might guess, yeah, this is going to be one that there are going to be two solutions for. So let's just try to draw this out a little bit, and again, I'm not great at drawing these things, but if this is A and B and C like this, so in this case A is 72, and little a is across here at 21, and little b is here at 22. So again, the first thing I want to try to do is figure out that h value. That will be kind of helpful, I think. So h in this case is going to be the adjacent side, which is 22, and I'm going to multiply that by the sine of that angle, which is 72 degrees. Again, make sure your calculator is in degree mode for this. And when you calculate this out, you get 20.9. And so sure enough, here's a case where that h value, which I just calculated, is less than the opposite. That's the next biggest one, which is less than the adjacent. And if you look at that chart we just did, sure enough, as soon as we get this type of scenario, this is a case where that has two different solutions. So I'll try to run through each one here so you can get a feel for what that looks like. We're going to use the law of sines to help us find each of those solutions. But there's just one little tricky part here. So when I do this, I do need to figure out my values. I need to figure out angle A and B and C, and then side A and B and C. Now right now I already know that angle A is 72, and little a is 21 and little b is 22, so I need to find these other features here. So I'm just going to go right to work using that law of sines. I'm going to say the sine of 72 over 21 equals the sine of b, let's say, over 22. And when I do my cross multiplying and dividing here, I am ultimately going to end up here with the sine of b equaling 0.99 something, I think. And if I go ahead and do my inverse sine just to the nearest degree, I'm going to get that b equals 85 degrees. Alright, so that's fine, so I can write that down. I'm going to change my colors here a little bit. So b is going to be 85 degrees, and that means that obviously all the angles in a triangle add up to 180. So if I calculate this out, that means that angle C should be 23, I think. And then I can run through that law of sines once again to help me find this other missing side here. That's going to end up to be 8.6. So now you probably wonder, well, where does the other solution come into play here? This seems pretty straightforward. We've done stuff like this before. Where does the other solution come into play? Well, slide, which has the same information here, When I did that inverse sine equaling 0.99, recall that your sine values, your y's, and so that's going to be way up here. That's where that 85-degree angle came from. But do you see that there's another angle now that also has that same y value, just a little bit bigger than 90? It's going to have that same reference angle of 85 degrees, but it's actually going to be 95 degrees. 95 degrees. So now, when I write my angles and sides out again here, I still have to have my A angle being 72 and little a being 21 and little b being 22. But now I'm going to change my angle here. My angle B can not only be 85, but it can be 95. That, of course, is going to change my angle C here to 13. And then when I go ahead and do my law of sines once again, then I'm going to get a different side here for side C. That's going to end up to be 4.9. So here's the secret right here is, and this is why there is that extra possible triangle sometimes with this certain condition, is simply because of being more than one angle that satisfies this sine requirement here. So again, see if you can follow through with that. We're going to keep practicing on these some more in class, but that's the law of sines, the ambiguous case. Thanks for watching, and we'll see you guys in class.